Welcome everyone to IDC 451 seminar presentation. I am Pradesh Varun Das, a student from the Department of Physical Sciences at ISER Mohali. Today, I'll be presenting my seminar on the topic, a high-resolution spectral analysis of 3 carbon-enhanced metal poor stars, published in the Journal of Monthly Notices of the Royal Astronomical Society in the year 2006. First and foremost, let us know the basic structure that we will be following to understand the paper by outlining the content in a nutshell. The paper presents analysis of a high-resolution spectra obtained with the Subaru telescope high-dispersion spectrograph of 2 carbon-enhanced metal poor stars named as the HE13050007 and the HE11520335. We have also taken the case of a classical CH star named the HD5223. In order to understand their salient features, it is essential to know the taxonomy of the CHEM stars and then develop the spectral analysis using the IREF DS9 software that enable developing and removing the various biases to obtain the final nature spectra. On obtaining the reduced spectra, then we calculate the radial velocities and the effective surface temperatures of these stars using the BVRI photometry method. Finally, we analyze the spectral abundance analysis of various elements to know the composition of the stars and then segregate them under the taxonomy of the CHEM stars. At the end, we present the results and the interpretation that the paper concludes. On the basis of the composition of the elements detected from the CHEM stars, the authors have suggested their subclasses to be of the following 4 types. The CHEM R enhanced stars. These exhibit the presence of strong enhancements of rapid process elements. The CHEM S enhanced stars. These exhibit the presence of strongly enhanced slow process neutron capture elements. The CHEM RS enhanced stars. These have contributions from both the S, that is the slow, and the rapid neutron capture processes. And finally, we have the CHEM no stars, which have no enhancements of any of the neutron capture elements. It has already been found out that a single mechanism for the production of the enhanced carbon in these stars would be actually highly unlikely to lead to such a diversity of heavy element abundance pattern. Therefore, in order to obtain insight into the possible origins of these CHEM stars and to place additional constraints on the nucleosynthesis of these neutron capture elements at low metallicities, it becomes essential to conduct their high resolution observations. The spectroscopic observations of these programmed stars were carried out with the high dispersion spectrograph, where each object spectrum has been taken with a 10-minute exposure. Now, the spectra of these stars are very typical of the complex combination of molecular and atomic absorption features in their respective cool atmospheres. These have very closely spaced molecular absorption lines of the CH band, the CN band, and the Swan system of C2 bands. Now, from the continuum spectra, it is visible that the atomic absorption lines are getting overwhelmed by the molecular transition. As a consequence, we could only get a few strong spectral lines and hence can calculate the equivalent widths to obtain their elemental abundances. There has also been search for lithium abundance in these programmed stars. It's because a wide spread of lithium abundances is actually believed to exist among the CHEM stars. However, in the giants, it is not expected to currently exist on the stellar surfaces due to its likely destruction from the internal mixing processes. For the 3 programmed stars discussed, however, there has been no such detection of lithium, which speaks of their relatively older age in the universe. The radial velocities of these programmed stars are measured using several unblended lines in the nature spectra. The estimated heliocentric velocities have been calculated for the 3 stars as below. For the 2 stars, that is the HE1305 and the HE1152, the radial velocities have been calculated by obtaining the data from the SIMBA database. And for the SD5223, it was found that it was rather a radial velocity variable star whose velocity ranges from 230 kilometers per hour to 250 kilometers per hour. And then using the BVRI photometry, several bands are used to estimate the effective surface temperatures subject to the input metallicities of these stars. Hence, through the IREF software, it is possible to calculate the temperature of these stars as here. For these 2 stars, we have the temperatures 4750 kelvins and 4000 Kelvin respectively. However, for the star HD5223, we obtain a temperature of around 4500 Kelvin. Now there is an interesting thing here. The broadband BV color index is often used for the determination of the effective temperature. However, the BV color index of a star with strong molecular carbon absorption features depends not only on T effective, that is the effective temperature, but also on the metallicity and on the strength of its molecular carbon absorption features of the stars. This happens primarily due to the effect of CH molecular absorption in the B band. For this reason, the authors have not used the empirical effective temperature scale for the BV color index. Rather, they have calculated the effective temperature in the other bands where the JK, JH and VK bands provide similar temperatures and the VI band provides a relatively higher temperature. Now, after obtaining the reduced nature spectra of the star, the spectral analysis of the various characteristic elements is done, which then would classify the three camp stars easily. First, we understand the carbon abundances in the program stars. Here we could see that the graphs compared the fits of the synthetic spectra with the observed spectrum of He1305, He1152 and HD5223 respectively, shown by the solid circles in the wavelength region of about C2 swan bands. It has been observed that out of these three stars, carbon is strongly enhanced in He1305 relative to the solar photospheric carbon abundance, where we could see that the synthetic fit matches closely to that of the experimental observations. Now, the second important elemental abundance to be discussed is the presence of light slow process elements and heavy slow process elements. On the left side, we have plotted for the light S process elements, and on the right, we have the heavy S process elements. On the left, in the reduced spectra of He1305, we could see strontium 1, yttrium 2, and zirconium 1 present in overabundances. Similarly, in HD5223, we could also see a similar abundance of strontium 1, yttrium 2, and zirconium 1. On the other contrary, in the third star, He1152, yttrium 2 and zirconium 1 are found to be almost solar. Therefore, due to the highly blended spectrum of strontium, its synthesis calculation is not possible. Therefore, these elements are not obtained in its spectra. Therefore, we obtain heavy S process elements in this particular star, unlike the other two stars on the left. Now, finally, the paper discusses about the abundance of europium 2 and lead 1 in the star He1305, which is the characteristic elemental presence that speaks of the abundance for both rapid and slow enhanced process elements in this particular star. We could see two significant europium 2 lines present in the spectra at about these wavelengths. And also we could see an abundance of lead 1 spectra here too. With this, the key elemental abundances of these crucial elements were conducted for the three stars, which were now analyzed to categorize them under the taxonomy. It was found that the star He1305 was rather a Kemp RS enhanced star, whereas the other two stars, that is the He1152 and HD5223, both belonged to the Kemp S process star. The radial velocity measurements indicated that all these stars were likely to be highly velocity stars and expected to be the members of the galactic halo population. On obtaining a more precise metallicity, we can also predict the effective temperatures more precisely. The CH stars like the SD5223 discussed here are characteristic of their mass transfer phenomenon from a companion star that has now undergone to become an asymptotic giant branch star. With this, I thank you for giving me an opportunity to read, understand, present our term paper. For more details, one can also refer to this particular paper, that is a high resolution spectral analysis of 3 carbon enhanced metal poor stars. Thank you for your patient hearing.